Okay, hello everyone. So today I'm going to give you a very short tutorial on the few topics that we have studied so far. So this can help you figure out how to answer questions and address assignments and so on. Okay. Um, the topics that we have covered so far are the ones that you see over here. So we did an introduction to secure communication. We talked about overview of wireless communication systems, talking about different technologies and their characteristics and so on. And then we talked about wireless network security, which was mainly about the challenges in wireless network security or security challenges, and then mostly focused on Wi-Fi. We're going to address one problem in each one of those topics as a quick tutorial. This might help you go through your assignment successfully and also prepare for uh, your quizzes and exams and so on. Okay, so and it gives you an idea how the problems in this aspect are addressed. So let's start with the first problem. This was related more to the introductory part when we talked about the main pillars of security, the confidentiality, integrity, availability, those three layers that were defined for secure communication systems. So the question here says, and it's very similar to one question that you got in your assignment, but it's with different applications. So it says, consider an automated payment gateway system. So this is one of those I don't know if you know about those online payment systems that are used to pay your bills and stuff like that. So consider an automated payment gateway system where user pays for an item using their account via the payment gateway. So when I connect, for example, PayPal is such an example. Okay, so you provide that payment system your account, and then later on when you want to pay, you just say pay this amount for this particular vendor based on that particular invoice, and just charges this amount to your account that was provided to the online payment system. Okay, so that says for such a payment system, give examples of confidentiality, right? So integrity and availability requirements associated with the system. So the idea here is to look at the different components of the system and the different types of information that flows through the system and figure out among the components and the information what are some examples of confidentiality, integrity, and availability. And the idea here is for each one of those, give an example where the particular property is highly important. Okay, so again, you can find that confidentiality applies almost to everything, but the idea here is to figure out where are the main pieces of information or components where confidentiality is really essential, is a very high priority. Similarly, parts of the functionality or the information flowing through the system where integrity is a very important and key feature or requirement, and similarly for availability. So let's think of those systems, right? What happens in those? I'm just trying to go through the thought process with you. So you have this gateway, payment gateway system. You have um, your account information, right, which is typically provided to the system, right? You have also your own, I mean, to figure out that you actually own this account, you need to be authenticated into the system as a person who owns really that account. So there is some kind of authentication, and that authentication has to connect to your account as well, right? Um, and then there is a provided input by you, which is an amount of payment, right? And then as an output of this system, you have a particular process payment, which is related to the amount of payment, right? And actually charged to your account, right? I mean, this figure is not, I mean, you don't need to draw this figure. I'm just doing it to understand and to describe for you what's going to happen here, okay? So let's see. If we talk about confidentiality, definitely your authentication information is very important. Nobody needs to see it. Otherwise, those people who see it will have access to your account, right? If they figure out your authentication information that allows you to say, charge this account, then they can also charge you, right? Similarly, your account information itself is another. So for those two, I can say that confidentiality is a big issue, right? So for this one and for this one, I need really confidentiality, right? That's the key factor. Okay. Now, the amount of payment that I allow the system to do, if this amount of payment is allowed to change at any point in time after I set it, then I'm gonna lose money, right? So it's important for this part of information to have integrity, right? So I should not allow anyone to change this information, otherwise I'm gonna lose really a lot of money, right? And then from a merchant point of view, if I am a supplier and this system is not working all the time, or if I am a buyer and this whole system is not working all the time, then I'm gonna really be pissed off, right? I want to buy something and I cannot buy it, or as a supplier, I'm losing opportunities for people. So the availability of the gateway system itself, right, is another. Okay, I mean, okay, you might be able to find some other aspects to this system. Okay, so but again, in my opinion, these are the key factors. So in answering this question, you would say that with very high priority, I need confidentiality on my account information and my authentication, right? Information. I need very high integrity, and I should not allow anyone to change anything related to the amount of payment that I want to pay, right? Otherwise, I'm going to lose money. It's going to be charged to my account without my permission, right? And last but not least, I need the whole system to be available all the time so that I can, or with very high availability, so I can actually process my payments before I lose services or I miss opportunities, whether I'm a seller or a buyer, right? So it's more or less kind of the analysis that we do for such system. Okay. I'd be happy to receive some questions if you have, or some extra suggestions that you have. You might post these suggestions to the Blackboard, send them by email. I'll open a blog for this, so you can exchange ideas as well, if you'd like, because these are, um, again, these kind of questions might have more than one possible answer, and the idea here is just to provide an example for each one of those properties, the integrity, the availability, and the confidentiality, where they are really a high priority. Okay, let's move on to the next question. Um, so, next question says that if you have a network and you are the network designer, you are required to connect a set of large size storage devices like hard disks, for example. So you have those hard disks which have large sizes, right? And you want to connect them to a main server. So I have here like a main computer system, and those needs to be connected as storage devices. Right? That's what happens typically in data centers, right? Which is happening inside a data center. So that's basically in like more or less small area place, right? That's a data center. And then the connection needs to be wireless. So that's number one. We're not allowed here to use wired connectivity. And it's required to have, again, this connection, by the way, is two ways, and it is wireless, right? So I would just represent wireless with this like whitening sign. And it's at least 1 gigabit per second, right? So that's really high speed connectivity. And then it says discuss the main characteristics of this wireless connectivity and which modern wireless technology would be suitable to use for this connectivity. So in terms of the characteristics, it's a very small area, right? It's local, or even smaller than local, short distance, right? And very high speed, right? Now, what are the technologies that can be used for short distances? First of all, so we have things like Zigbee, some of those that we have discussed, right? We have the Bluetooth, okay. We have something like Wi-Fi, okay. And um, it's a small area, high speed, and reliability as well, right? It's very important. Okay. And more modern technologies would be something like millimeter wave, um, right? And maybe even terahertz communication. Now, most of these technologies, they would work, but they actually lack the speed. Probably the ones that might achieve this kind of speed are the millimeter wave and the terahertz communication. And both of these requires line of sight, but since these are devices connected to a server which is within the same location, so typically they are in the same room, right? So this is more or less also same room, so they have line of sight. There are no obstacles and so on. Then probably I would choose either millimeter wave or terahertz communication because those two can provide me with the high speed that I require, right? Uh, so again, might have different ideas. You might want to discuss maybe something like Wi-Fi, but to reach the level of 1 gigabit per second in a reliable way for each connection, that's very difficult for Wi-Fi, unless you have really very modern Wi-Fi, knowledge about very modern Wi-Fi that can do this reliably for multiple devices at the same time. And in that case, provide your discussion is going to be accepted, but as far as I know, the Wi-Fi cannot do this. Of course, Bluetooth and Zigbee, they are no match for such speed. Okay, so that's why I would choose those more modern millimeter wave or terahertz communication. Okay, and the argument, as I mentioned, it so you have to make sure that it works and it also in this scenario and it achieves the requirements of connectivity. Again, suggestions, discussions can be done on Blackboard in this topic if you like. Okay, here is another um, question that talks about wireless network security and says that the IEEE 82.11 Open System Authentication simply consists of two communications. So to authenticate for an access point to, for a patient to authenticate with an access point, only two steps. First one, authentication request sent from the station to the access point, including the MAC address, which is the station ID. And then it's followed by an authentication response from the access point to the station saying authenticated or not, and also should include the MAC address of the station. Okay. Um, so for such a scheme, can you think of some benefits of this scheme, good aspects of the scheme, and some security vulnerabilities of this scheme? So again, in this case, let's draw this. So you have the station, right? And STA, and you have your access point, right? AAP, and the authentication is very simple. So authentication requests or request associated with this is the MAC address of the station, and then an authentication response, which is either yes or no, and it should also include the MAC address of the access point. Okay. Um, what are the advantages? So if you want to think of an advantage, it's simple, right? Very simple, very quick, does not take time, does not take much processing, right? Still, it might have some protection, right? Because you provide information such as the MAC address and so on, so it still has sufficient protection. If the MAC address is not allowed to that access point, you'll not be able to communicate, right? very open system. Bad aspects of this system is that it assumes trust, right? Assumes, okay, trusted behavior, right? What do I mean by this? It just assumes that nobody's gonna fake the MAC address, for example, which can happen actually. So if I have a list as an access point of allowed MAC addresses, which are the devices that I want them to communicate, well, how do I get the information? It's actually sent to me through the request by the station itself. And if the station sends the fake MAC address, then the access point, it's not the actual station MAC address. The access point might find that in the list and then says, okay, get in, while the actual device should not get into the network, right? So this is the good, this is the bad, in my opinion. Okay, so that's again kind of questions that you might get in order to kind of think, analyze, and maybe also I would have asked you to represent the authentication operation using the time sequence diagram, right? The one that we see here, very simple one, but again, I didn't ask in this question, but I may ask you in variations in this question. Or I might give you the time sequence diagram without a description, and you understand what's happening, maybe describe it, maybe analyze it as well from the goods and the bads. Okay, so that's again another example of questions that you might get. I hope this very quick, very short tutorial, which includes a variety of questions among the different three topics that we have covered so far, gives you an idea how to approach your problems in the assignment and also in the upcoming quiz and so on. Okay, good luck. Thank you. Looking forward for discussions if you have any that are going to be in Blackboard. Thank you.